Kerry Holley is a nationally recognized author, engineer, and thought leader. He was inducted into both the National Academy of Engineering and the National Inventors Hall of Fame, two of the highest honors in his field. He's worked for organizations that you may have heard of, like Google and IBM and Cisco. Been on the board at DePaul University in Chicago, and over his career, Kerry's helped major systems from Fortune 500 companies to healthcare networks use technology to solve complex problems and serve people more effectively. Shane Orlick is a business leader and an innovator in all things AI. He's held executive roles at WalkMe and Jasper, helped redefine how people use technology to communicate and to work. Shane now serves as the Chief Operating Officer at Wand AI, a company that builds collaborative AI agents designed to work alongside human teams and improve productivity and decision-making. One other hope I have for you this evening is that you learn more quickly than I could understand what a collaborative AI agent is. But I now know, thanks to Shane. And beyond their professional accomplishments, both Kerry and Shane are longtime members of the San Domenico community. Each has children who've graduated from SD, and both have children currently attending. Kerry's daughter Aaliyah is in grade 7. Shane's son Brooks and Wilson are in grades 8 and 9. We're especially glad to welcome them tonight, not just as experts in the field, but as thoughtful, engaged members of our community. So with that, please join me in welcoming Kerry and Shane. Okay. So I think as we get started, we should start with a little definitional work. I would love it if each of you, maybe Kerry, we'll start this one with you. Could you just define AI in plain language, especially for parents and educators who don't work in tech? We've all come here to talk and think about AI. We all talk and think about AI frequently. But how would you define the term, Kerry? Can we start with you?
I would love to define the term, and many of you know that AI has been a term that has been out there since the middle 1950s. Then and now, we've always thought about AI as being to use computers, to be able to use machines, to do things that we previously thought only humans can do. So that's a very simple definition. But AI, artificial intelligence, is also a field of computer science, a field that includes many different disciplines. One of the breakthroughs of AI was something called machine learning. And that breakthrough really occurred in the 1990s. When you think about your iPhone, you think about the self-driving cars, they all use machine learning. And what is machine learning? It's being able to use data to identify patterns and to make predictions and to make decisions. So when you think about maybe something as simple as recognizing that an image is a cat, we can do that with machine learning because we've trained the computer on thousands of images. So it's like giving a student the cheat sheet. So we give it the cheat sheet, these images. We've told it this is a cat, all these variations. And now after the training, the AI can say, yes, this is a cat. So that breakthrough of machine learning was really significant. It powers many of the technologies like ChatGPT you see today. But there's a subset of machine learning called deep learning. Now, deep learning, you may have heard the term, it's really taking machine learning, which you can think of as a layer, and then having stacks of layers that are deep. Maybe machine learning is one layer, and my stack is 10 layers, each of increasing complexity. Each of these layers is really nothing but math. This is why math is important again, your calculus. But the point I'm making is that in 2012, a local computer scientist, Fei-Fei Li, showed us that we could do better than just the basic machine learning, that we could do more complex pattern recognition with deep learning. And when I say pattern recognition, this is what we see with tools like Claude AI, Perplexity, Gemini, ChatGPT. So even though it seems magical, what's really occurring is that we're now using the same type of technology to determine that it's a cat versus a muffin. We're now using it with language. Google produced a paper in 2017 which really made this possible. This paper was titled "Attention is All You Need." But because of that research that Google did, we were now able to introduce new architectures in the mix. But when you think about you and I who take a manuscript, a document, and we send it through ChatGPT, when we ask it to improve on this document, I know it seems like magic, but what's actually happening is that we're using what I just described, deep learning. We're using and creating a statistical representation of that question and answer. So when I talk about a statistical representation, I'm just talking about math, that we can actually represent good versus weak writing. We can actually represent good grammar versus bad grammar. You name it, it can be represented in math. And because we can represent it in math, and because now we're doing computation at a scale never before seen in human history, this massive scale of computation gives you the impression of understanding, but it approximates human understanding. It is not human understanding, but it approximates it such that you might argue, what's the difference? But that, in a nutshell, is AI.
I was looking at some of the teachers in the crowd. When you said cheat sheet, you lost a few of them. But when you said math was important, I saw a few just perk right back up. Yeah.